find the missing angle lengths and angle measures. So what is a right angle triangle? Before discussing trigonometric ratios, what is a right angle triangle? A right angle triangle is a triangle in which one of the angle is of 90 degrees. Okay, so let's say we have a triangle ABC in which the angle C is 90 degrees, as you can see here. Let's say angle at A is theta. We're naming it as a theta, and the other side B, nothing, no angle is there. All right, so let's see in a right angle triangle, how do we name the sides? The side which will be opposite to the angle theta, you call that opposite side. So that side is named as opposite side, which is basically BC here. BC is the opposite side, and the side between the theta and the 90-degree angle, you call that adjacent side. That is adjacent or base. You just, mostly name it as adjacent, yeah. And the side, the longest side in a triangle, which is opposite to, 90-degree angle, is called hypotenuse. So these are the three sides which we name in a right angle triangle. Now, what are the trigonometric ratios? Trigonometric ratios are basically the proportional lengths on a right angle triangle. So the ratios I'm going to write now are only applicable to the triangles which are right. If the triangle is not right, means if at least one of the angle is at 90 degrees, you can't apply sine theta, cosine theta, and tan theta ratios on that. So since it is a right angle triangle, so my sine theta ratio. And the purpose of using sine, cos, and tan is to basically measure the missing sides in a right angle triangle and the missing angles. So what is sine theta ratio? Sine theta, you need to learn them, is always going to be opposite over hypotenuse side. So opposite side over hypotenuse side. Do not mix the opposite and adjacent side. The longest one is going to be the hypotenuse always. And the side between the theta and the 90 degrees is adjacent. And the side opposite to theta is called opposite side. So sine of theta, sine of the angle, which is theta, is always going to be opposite over hypotenuse. And the second one, cosine theta, second ratio is cosine theta, which is going to be adjacent over hypotenuse always. Adjacent side over hypotenuse side. Similarly, the third ratio, so the proportion of lengths used here are opposite over adjacent is going to be a 10. If it is hard to learn that way, like how would you learn what is sine, cosine, or tan? We usually use SOH CAH TOA for that. SOH CAH TOA. What does it mean, SOH CAH TOA? So mean S for sine, O for opposite, H for hypotenuse. So it's easy to learn. Sine is going to be opposite over hypotenuse. Ka, C-A-H, ka means C for cosine, A for adjacent, and H for hypotenuse. And TOA, in TOA, T is for tangent. Tan is basically opposite over adjacent. So if you really find it hard to learn these proportional lengths, you can just simply, remember it by SOH CAH TOA rule. Okay, now let me just tell you the reverse. These cosec theta, secant theta, and cotangent of theta are basically the reverse of these trigonometric ratios. So the reverse of sine theta is basically cosec theta. So if my sine theta is going to be opposite over hypotenuse, then the cosec theta is going to be hypotenuse over opposite. Similarly, secant theta or sec theta is going to be the reverse, means the reciprocal of cosine theta, which can be written as hypotenuse over adjacent, because I'm taking the reciprocal of the cosine value, which was adjacent over hypotenuse. So now it's going to be hypotenuse over adjacent. And the third one is tan theta. So the reverse of tan theta is cotangent of theta, and you can simply write it as adjacent over opposite. Now let's just do some examples to understand them better, like how we can find the missing lengths and angles in it. Okay, let's say we have to find the length. When one angle and one side will be given in a right angle triangle. So here you have a triangle ABC in which AB length is given to be 5 and angle at B is given to be 30. So you have to find AC and BC lengths. AC and BC length. Okay. So what is the rule? When one angle and one side will be given, you can always apply SOH CAH TOA as we learned above. SOH CAH TOA. So let me tell you here, we have to find AC. If you, observe that AC is the side called opposite, because as I mentioned above, that the side opposite to the given angle is going to be the opposite side. And here BC is your adjacent side because it is between the angle theta, I mean the angle whatever it is, it can be 30, 50, 60, whatever, and the 90-degree angle is the adjacent side, okay? And the side opposite to the C, which is 90 degree, is the longest side, which is called hypotenuse here. All right, so since we're going to find the AC first, okay? We're going to find the AC length. So we are going to use SOH CAH TOA. So I observe here, I'm given the hypotenuse length and one angle. So it means that, and I have to find the opposite. Means if my hypotenuse is given, and my theta is given and I have to find opposite side, so I better use a sine rule, okay? I mean not the sine rule, sorry, sine trigonometric ratio. So it's going to be sine of theta, since sine of theta is opposite over hypotenuse, and theta is 30 degrees now. So sine 30 degrees is equals to opposite side, which is unknown, so I'm just going to write it as AC over hypotenuse. So the hypotenuse here is 5. Now you just need to simplify the fraction and get your AC. So 5 is getting divided with AC. So when you will move it on the other side of equation, it will get multiplied. So 5 in division, when taken to the other side of equation, gets multiplied to that side. So 5 gets multiplied with sine of 30 is going to be your AC. So your AC length comes out to be, okay, so you can just put it in the calculator. Sine 30 will give you, 1 by 2. So 5 times 1 by 2 is going to be 5 over 2. So your AC length is 5 over 2, which you can write here and label it with AC. That's 5 over 2. Now let's talk about BC length, because we do have to find BC also. So if I just move above, yeah, now you can notice, again, you're going to apply the SOH CAH TOA. The adjacent is missing, so you can either use the tan here or the cosine here, because if I use cosine, to find BC, I'm going to use the cos of theta, the CAH value. So CAH, in SOH CAH TOA, I'm going to use CAH, means cosine theta, which is adjacent over hypotenuse. So you know that your theta is 30 degrees. So you just mention your theta is 30 degree here. And adjacent length is missing. So I'm just going to put BC there, because BC is, not given, over hypotenuse. Hypotenuse is 5 centimeter, as you can see. So it's going to be 5 here. Again, because you have to find BC, so you're going to get rid of the 5, which is in division with BC. So when you move 5 on the other side, it gets multiplied with cos of 30. And cos of 30, if you will put it in the calculator, will get you root 3 over 2. Yeah, root 3 over 2 times 5 is going to be 5 root 3 over 2. And that is your BC length. That's 5 root 3 over 2. 5 root 3 over 2. Here we go. Now, so this is how you can find the missing length if one angle and one side is given. You can always use SOH CAH TOA there. Now, in next thing, when you have to find the angle and sides are given. So if you notice here, you are given AB side in a right angle triangle and AC side, which is 15. And let's say we have to find angle B, okay? let's say we get to find angle B. So what is angle B? So I'm gonna label it. That's your angle B here. Let's label it with X. As you notice, we need to identify the sides. So your AC side, okay, so the side between the angle and the 90 degrees, we always call it adjacent. So this is going to be, your BC is going to be your adjacent side. And the side opposite to the 90 degree is going to be the longest side, which is hypotenuse. So 30 is your hypotenuse, means AB. And AC is going to be opposite because it is opposite to the given angle. Fine. So angle B, as you know, you now need to find what two lengths are given. So we are given opposite and hypotenuse. The opposite and hypotenuse is given. So using SOH TOA, you know that the length, the ratio which will have opposite and hypotenuse in it is going to be the sine ratio. So I'm going to apply sine of x because my angle is x is equals to opposite, which is 15 over hypotenuse, which is 30. So this is going to be sine of x is equals to, when you will simplify 15 over 30, it is going to give you 1 by 2. So now the thing is, you don't want sine of x, you only want single x, the angle which is x. So the thing is, you have to remove the sine ratio along with the x. So remember, whenever you move the trigonometric ratio on the other side without the angle, they always get reversed. So when I move the sine to the other side, take it out of the x, moving it on the other side it becomes sine inverse of a half. So when you will put it in the calculator and you will find out the sine inverse of 1 by 2, you will get x to be 30 degrees. So your x is 30. So this angle x, which was x, is 30 degrees now. So here you have 30 degrees here, okay? So this is how, in a right angle triangle, you can find any missing angle if the angle is missing, they must give you two sides. So identify those sides and then use the, appropriate, trigonometric ratio according to the given sides and then find your angle. Remember, when you move the sine, cosine or tangent to the other side without the angle, they always get inverse. They always become inverse. All right. So the third thing is here in this question again, we will see. Okay, so we will see, we have to find, let's say we have to find angle theta. So we have to find angle theta, A, which is HA. So you can say, fine, you identify your ratios, AC ratio and BC. AC side, so the side between theta and 90 degree is always adjacent. So this is adjacent. And the side opposite to the given theta, the given angle, is called opposite side. So that's your opposite side. Now we are going to find the theta angle. So looking at the given sides, we are given adjacent and opposite. So the only third tangent is applicable here in SOH TOA. SOH TOA. You could see that in TOA, you're having adjacent and opposite, which both are given. So yeah, you're going to apply SOH TOA there. So you say my tangent of theta is opposite over adjacent. So I know that the opposite side is 1 over adjacent is also 1. So 1 on 1 is 1. So again the same rule, when you will move the tangent to the other side, it becomes reverse because we want theta. We don't want tangent of theta. We only need theta. So what you have to do, you have to move tangent on the other side. So it becomes tan inverse, 1 on 1 is 1. So tan inverse 1, you can do it on your calculator. It is going to be 45 degrees. So this theta here, we found out that it's 45 degrees here. So this angle, theta, angle at A is 45 degrees, fine? Yeah. So this is how we can find the unknown angles. Now look at the third thing. How to find the side length when no angle is given. Okay, in a right angle triangle, they are not going to give you the angle now. In the above questions, we saw that they were at least giving you one angle and one side to find the rest of the things. But in here, they will not give you any angle, only maybe two sides, but they will give you two sides, okay? So in that case, when no angle is given, we always apply Pythagoras theorem. What does Pythagoras theorem say? And remember, it is only applicable to the right angle triangle. So what does Pythagoras theorem says? It says that when you take the square of the longest side in a triangle, which is hypotenuse, the square of hypotenuse is going to be equals to the square of adjacent plus the square of opposite. Means the square of the longest side, which is hypotenuse, is going to be equals to the sum of the squares of the other two sides, okay? So this is the Pythagoras theorem. Now let's apply it in a question. So here you're given ABC, a right angle triangle, in which AC length and BC length is given. And you have to find AB. So first you saw that there is no angle given, means that is theta, but it is unknown. Now there is no 30 degrees, 45, like no value is given to the theta, means we don't know any angle given. So we have to find AB now. In AB, you see AB is the longest side because it is opposite to 90 degrees. So that is going to be the hypotenuse. And the rest of the other sides are AC is adjacent as it is between theta and 90 degrees. And 5 is opposite side as it is opposite to theta. So according to the Pythagoras theorem, I'm gonna use my statement above, which says that the square of hypotenuse is always equal to the square of the sum of the adjacent and opposite. So my hypotenuse is missing here, which is AB. So I write AB squared. My AB length represents the hypotenuse. So AB squared equals to adjacent squared, which is 12 squared. So 12 squared plus opposite squared, which is 5 squared. So 5 squared. So AB squared is equals to 12 squared is going to be 144 and 5 squared is going to be 25. When we add them both, we get 169. But you know that it's a square of AB. We don't want the square of the AB length. We only need the single AB. So to remove the square, you will take square root on both sides of equation, and that way you will get, so this square over the AB gets cancelled out with the square root, and AB comes out to be the root of 169 is 13. So AB length is 13 here. So the hypotenuse, our hypotenuse is 13. Here it is. So again, it's the AC, which is the similar question. As you can see, the AB length, which is the hypotenuse. So hypotenuse is given, and 4 BC length, which is the opposite side. Since this side is opposite to theta, so we call it opposite. And AC is missing, which is the adjacent. So adjacent is missing. No angle is given. We're going to use the same Pythagoras theorem. So Pythagoras theorem says the hypotenuse square, which is 9, square equals to the square of adjacent, which is AC. That is unknown, so I'm just going to write it as AC. AC square plus the opposite square, which is 4, so 4 square. Now we have to find AC. So I need to get rid of every term which is with the AC. So what I'm going to do, 9 squared is going to be 81 equals to AC squared plus 4 squared will be 16. So I move the 16 on the other side. So it becomes 81 minus 16 equals AC squared. Now 81 minus 16 is going to be 5 and 8, 7 minus 1 is 65, okay? So AC squared, but I need the AC only, so you don't want the square over the AC. So to get rid of that square, you will square root both sides. So your AC will be square root of 65, okay? If you want the decimals, because it doesn't represent a perfect square number, you can just put it in the calculator and it will give you the decimal number. So your AC is 67. So this is how the trigonometric ratios works to find the missing lengths and angles in a right angle triangle. So this is it for today.